So now the question is how to calculate the frequency of the radiation emitted. In 1885, Balmer and Rydberg discovered a formula that allowed to calculate the wavelengths of the radiation emitted. It was discovered in 1885. It explained the presence of the visible lines and it calculated the wavelengths. This is the formula known as Balmer-Rydberg formula. 1 over lambda equal RH 1 over n square minus 1 over n prime square. And n is the initial level and n prime is the final level. And n is less than n prime. If we suppose, for example, the electron was initially found at n equal 2 and it passed to n equal 5. So when the electron returns from 5, it will emit light of wavelengths lambda, and this radiation or the wavelengths can be calculated by the formula of Balmer-Rydberg 1 over lambda, and lambda, pay attention, is when the electron return from 5 to 2 in this case, is equal RH, which is the Rydberg constant and is given in the exercise or the exam. N in this case is the initial place of the electron we supposed at level 2, and n prime is the final state of the electron we supposed in this exercise we suppose is equal to 5. So I will say 1 over lambda when lambda return from 5 to 2 equal RH 1 over 2 square minus 1 over 5 square, and by this way I can calculate lambda. So Lehman, we have in hydrogen, we have 1 electron. The question is, what is the energy level of this electron? Is this electron at level 1 or level 2 or level 3, 5, 4? Lehman suppose that the electron is found at n equal 1, and he calculated the lambda if the electron pass from level 1 to level 2, or from 1 to 3, from 1 to 4, from 1 to 5, from 1 to 6. And he found that if the electron is found at level 1, is supposed found at level 1, all radiations emitted are in the UV domain. Balmer supposed that the electron is found at level 2, at energy level 2. And he calculated lambda when the electron pass from level 2 to level 3, from 2 to 4, from 2 to 5, from 2 to 6, from 2 to 7, and he found that the radiations emitted are in the visible domain. Paschen supposed that the electron is at level 3, electron will from 3 to 4, 3 to 5, 3 to 6, or 3 to 7. He found that these radiations are in the infrared. And the bracket suppose the electron is found at level 4, and the fund suppose the electron is found at level 5. In the previous experiment, we see 4 lines. So we see only the visible transitions, or the transitions in the visible domain. And 1 over lambda, in some books, they don't write 1 over lambda equal RH 1 over n square minus 1 over n prime square. They write mu bar, which is equal 1 over lambda equal RH 1 over n square minus 1 over n prime square. And the nu bar is called the wave number, which is equal to 1 over lambda.